In this video, we're going to look at how Argand diagrams can be used with the equation of a circle. So I just want to remind you guys that the equation of a circle, it can also be written in the form of a complex number minus a plus ib, or bi, is all equal to the modulus, or we can just say the radius itself. So a plus bi represents the center of the circle on an Argand diagram, and r represents the radius. So an Argand diagram, just a reminder, is where the real axis is represented on the x-axis and the imaginary axis is represented on the y-axis. It tells you that in an Argand diagram, the points A and B are represented by 5 plus 4i and 1 plus 2i. So point A is 5 across and 4 up on the Argand diagram. So let's draw that very briefly. Again, it doesn't need to be like very accurately drawn. It's just for you to imagine it yourself. So this is position A, and position B is 1 plus 2i, which is 1 to the right and 2 up. And that will be somewhere here. So let's call that 1, 2, and we'll call that option B. Okay, we might as well label this one as well, since we labeled the other one. It says given A and B are the ends of the diameter of a circle. Okay, so it's going to be a very bad circle. But the fact that A and B form a diameter, and we also know that a diameter crosses the center of the circle, or the midpoint of the diameter is the center of the circle, that has to be useful in some form in this question. Find the equation of C in complex number form. Well, what do we need? We need the center of the circle, and we also need the radius. So let's take this step by step and start by finding the center. I'm going to increase the thickness of the pen, and like I mentioned, the center is the midpoint of AB, because that gives you the midpoint of a diameter gives you the center. So looking at the x-coordinates 1 and 5, the x-coordinate in between both of them is 3, and looking at the y-coordinates 2 and 4, the y-coordinate between both of them is 3 as well, because 2 and 4 have a difference of 2, divided by 2 is 1, and we add 1 to the lower one, so that gives you 3. Now putting that in the format of a circle, we have the modulus of z minus 3 plus 3i, all in a bracket, close the modulus, is equal to the radius. Now to form the radius, what I'd recommend is drawing an enlarged version of one of the coordinates on the circle and also the center. Why that helps is you can then form your own right angle triangle and find the magnitude of the right angle triangle, or the hypotenuse of the right angle triangle. So here 3, 3 represents the center, and 5, 4 represents a point on the circle. The difference between the x-coordinates 3 and 5 are 2, and the difference between the y-coordinates 3 and 4 are 1. Using that, we can get that this hypotenuse is given by the square root of 2 squared plus 1 squared. Now 2 squared is 4, 1 squared is 1, 4 plus 1 is 5, so that's root of 5, gives us the radius. In that case, you can just leave it in this format, and this is the equation of the circle C in complex number format. This, by the way, says root 5, it kind of looks like root 3. Yes, sorry, I apologize for my handwriting, but hopefully this video helps. Be sure to leave a like if it did, and subscribe. I'll post a lot more content in the near future. Thanks for watching. Thanks for watching the video. I hope it helped. If you have any tutoring inquiries for A-level further maths, be sure to hit my website up at www.excellineducation.co.uk.